Welcome to our deep dive. Today we're taking a closer look at some of the most dazzling objects in the universe. Blazars.
They've captivated astronomers for decades.
Right. These celestial objects, blazars, offer a unique window
Into some of the most extreme environments in our universe.
Exactly. So to kick things off, what exactly are blazars?
In the simplest terms, they're active galactic nuclei, or AGN, with a relativistic jet.
A relativistic jet.
Yes, pointed almost directly at us.
Almost like a cosmic flashlight beam.
Exactly like that, aimed right at Earth.
Okay, so we've got these powerful jets of energy. What makes them so captivating?
They're incredibly bright. Their luminosity.
Oh, wow. That's what makes them stand out, right?
Precisely. That dazzling luminosity is due to a phenomenon. It's called relativistic beaming.
Relativistic beaming.
Imagine a fire truck speeding towards you. The siren's pitch increases, right?
Yeah, it gets louder.
As the sound waves compress.
Oh, I see.
It's similar with blazars because the jet is traveling at near light speed.
So fast.
Light waves get compressed.
Making them appear much brighter to us.
Yeah, it's like a cosmic spotlight.
Amplified by the jet's incredible velocity.
An excellent analogy. Now let's zoom in. At the heart of a blazar lies a supermassive black hole.
Whoa, a black hole.
An astronomical behemoth, you could say.
They're huge, right?
It draws in matter and forms a swirling disk of hot gas.
Is that what's known as an accretion disk?
You got it.
So this accretion disk, it's swirling around.
Yeah.
What happens next?
This disk generates vast amounts of energy, launching jets of plasma out into space.
Plasma.
Particles moving at nearly the speed of light.
Okay, let me see if I've got this straight.
Yeah.
We've got these incredibly powerful jets
Of plasma.
launched from a supermassive black hole.
Yes.
And because of their orientation and speed, they appear incredibly bright to us here on Earth.
That's a great summary. Now, you might be wondering how blazars differ from quasars.
Quasars. They do seem similar, right? Aren't they both powered by black holes?
You're on the right track. Both blazars and quasars are types of active galactic nuclei, but the key difference is the orientation of their jets.
Ah, the jets again.
A blazar's jet is pointed almost directly at us, while a quasar's jet can be at various angles.
So it's like looking right down the barrel
Yeah,
of a cosmic gun.
that's a vivid way to put it. Interestingly, there's a concept called the unified model.
Unified model.
It suggests that highly variable quasars could be powerful radio galaxies seen from different perspectives.
So depending on our vantage point, the same object could appear as a blazar or a quasar.
Precisely. And within the realm of blazars, we have two main types.
Two types, okay.
BL Lac objects, or BL Lacs, and optically violently variable quasars.
Wow, that's a mouthful.
Often shortened to OVV quasars.
BL Lacs and OVV quasars.
Got it.
What distinguishes these two types of blazars?
Their spectra hold the key.
The spectra.
Think of spectra as celestial fingerprints
Oh, interesting.
that reveal an object's composition. BL Lac objects have faint, or even non-existent emission lines in their spectra,
So they're kind of quiet.
while OVV quasars
The OVV quasars.
they have more prominent emission lines.
So they're louder, in a way.
That's a good way to think about it. Now, another intriguing characteristic,
Of blazars.
yes, of blazars, is their variability.
Variability.
Their brightness can fluctuate
It fluctuates.
rapidly, even within hours or days.
So they're like cosmic mood rings, constantly shifting.
While these dramatic variations likely stem from changes in the accretion disk,
Okay, the accretion disk again.
the jet itself,
The jet.
or interactions between the jet and surrounding matter.
So it's like a dynamic dance between
Ah.
these powerful components, constantly influence the blazar's appearance.
Exactly. To understand these complex interactions, we need to delve deeper into a blazar structure. Think of a blazar structure, like it has four main components.
Four main components.
Yeah. The supermassive black hole at its core,
Right at the center.
the swirling accretion disk, a donut-shaped structure of hot gas.
What's that called?
It's called a toroid. And of course,
The jets. Those powerful relativistic jets.
I'm guessing each part plays a role.
In its overall emission.
Yeah.
Precisely.
Yeah.
The supermassive black hole. It provides the gravitational force.
Right. The force that pulls everything in.
The accretion disk. It generates energy as matter falls in.
Okay.
The toroid can absorb and re-emit energy. And the jets act as powerful beams channeling energy into space.
So it's like a well-coordinated system.
And depending on which part of the blazar we're observing, we can detect different types of light. From radio waves
All the way to...
all the way to gamma rays.
That's a huge range.
You mentioned those jets traveling at nearly the speed of light.
They are incredibly fast.
Do we know exactly how fast?
Well, I know it's near the speed of light, but I don't know the exact speed.
The bulk speed of the plasma in the jet can be in the range of 95% to 99% the speed of light.
Wow. That's mind-boggling.
But here's where it gets even more fascinating.
Even more fascinating.
Individual particles within the jet
Can actually move even faster, zipping around in various directions.
So we're talking about speeds that are almost unimaginable.
It's no wonder these objects exhibit such extreme phenomena.
Speaking of extreme phenomena, earlier you mentioned something. Apparent superluminal motion.
Oh, yes.
Can you explain what that is?
Of course. Apparent superluminal motion. It's an illusion caused by the jet's extreme speed and its angle towards us.
Okay.
Imagine someone shining a flashlight across a distant wall. If they move the flashlight quickly, the spot of light can appear to move faster than the person's hand,
Even though.
even though the light itself isn't exceeding the speed of light,
This is a trick of perspective.
amplified by the incredible speed of the jet.
I see.
And this is one of the many reasons why studying blazars is so challenging. We have to constantly account for these relativistic effects.
To understand what's truly happening.
Exactly.
And I imagine observing these blazars isn't easy, given how far away they are.
Indeed. One of the closest blazars is still about 2.5 billion light years away from us.
2.5 billion light years.
That means the light we're seeing from these objects started its journey billions of years ago,
Wow.
long before our solar system.
Even existed.
Yes.
We're essentially looking back in time when we observe these blazars.
That's incredible.
So what kind of tools do astronomers use to study these distant and enigmatic objects?
Because blazars emit light. Across the entire electromagnetic spectrum, we need a variety of telescopes.
Each sensitive to different wavelengths.
For example, radio telescopes, like the Very Large Array. In New Mexico, they're used to study the radio waves emitted by blazar jets.
So it's a coordinated effort then, with different types of telescopes working together.
To paint a complete picture.
Yeah, of these objects.
Precisely. And it's this multi-wavelength approach that has allowed astronomers to make some incredible discoveries about blazars in recent years.
Such as, what are some of the most exciting recent findings?
One of the most significant findings came in 2017,
2017.
when the Ice Cube Neutrino Observatory in Antarctica detected a high-energy neutrino
Wow.
that was traced back to a blazar billions of light years away.
Neutrinos, they're those tiny, almost massless particles.
That can pass through almost anything.
Right.
They're incredibly difficult to detect.
Exactly. Which makes this discovery even more remarkable.
I can imagine.
It provided the first direct evidence that blazars can accelerate particles to incredibly high energies, producing not just light.
But also these elusive neutrinos.
So blazars are like cosmic particle accelerators.
Flinging out neutrinos along with those jets of plasma.
Precisely. And this discovery has huge implications for our understanding of how blazars work and their role in the universe's high-energy processes.
This is all so fascinating. It sounds like blazar research is constantly pushing the boundaries of our knowledge about the universe.
It absolutely is. And as technology advances and new telescopes come online, we're sure to uncover even more secrets about these enigmatic objects. Before we wrap up our deep dive, I'm curious, are there any lingering mysteries about blazars that continue to baffle scientists?
There's still many unanswered questions. One of the biggest mysteries is how those incredibly powerful jets,
The jets again,
are formed and collimated with such precision.
We know those jets are key to the blazar's incredible luminosity, but their formation remains a puzzle.
Indeed. We know that magnetic fields and winds from the accretion disk and torus play a role, but the exact mechanisms are still being debated.
And what about the variability? Do we understand what triggers those rapid changes in brightness?
That's another area of active research. It's likely that changes in the accretion disk, the jet itself, or interactions between the jet and surrounding matter.
So each of these components plays a role in the dynamic show we see from Earth.
It seems like every answer we find just leads to more questions.
That's the nature of scientific exploration.
And the pursuit of these answers drives our understanding of the universe forward.
Well, on that note, it seems we've reached the end of our deep dive into the captivating world of blazars.
Indeed. Though many mysteries remain, The study of blazars provides a unique window into the most extreme environments in the universe.
Thank you for sharing your expertise with us. And to our listeners, we hope this deep dive has sparked your curiosity about these incredible objects. Until next time, keep exploring the wonders of the cosmos. It's been a truly amazing journey exploring these powerful cosmic beacons. As we wrap up our deep dive, what are some of the key takeaways you'd like our listeners to remember about blazars?
Well, I think it's important to emphasize the sheer power and scale of these phenomena we're talking about. Objects driven by supermassive black holes, launching jets of plasma at nearly the speed of light across vast, vast distances.
Mind-boggling, isn't it, the distances and the speeds involved?
It really is. And as we've discussed, they're not just incredibly powerful, but also incredibly dynamic and variable. Their luminosity...
The brightness.
Exactly. Their brightness can change dramatically over very short timescales.
We talked about that earlier. It's amazing how quickly they can shift in brightness.
Yeah, blazars can change their brightness significantly in just a matter of hours. Or days. This rapid variability. It tells us something important.
What's that?
It tells us that the process is happening near the central black hole.
The heart of the blazar.
Yes. Are incredibly energetic and happen on very short time scales.
It's like a cosmic fireworks show with rapid-fire bursts of energy.
That's a great way to put it. And of course, we can't forget about...
The relativistic effects.
You got it. Those fascinating relativistic effects that come into play when dealing with such extreme speeds. Things like...
relativistic beaming. And apparent superluminal motion.
Yes. Those effects really highlight how our perception of the universe changes when we're observing objects moving at close to the speed of light.
A whole different ballgame when you're dealing with those kinds of speeds.
It certainly challenges our everyday understanding of physics.
Right. So, with all that we've learned, what are some of the big questions that still remain unanswered in the study of blazars?
There are still many mysteries out there. One of the biggest is the formation and collimation of those incredibly powerful jets.
We talked about how the jets are key to the blazar's incredible luminosity, but their formation is still a puzzle.
Indeed. We know that magnetic fields and winds from the accretion disk and torus play a role, but the exact mechanisms...
how they're formed and how they're focused so precisely are still being debated.
It's amazing to think that something as fundamental as the formation of these jets is still not fully understood.
It's a reminder that there's still so much we don't know about the universe. And what about the variability we discussed? Do we understand what triggers those rapid changes in brightness?
That's another area ripe for exploration.
Absolutely. That's another area where more research is needed. It's likely a complex interplay of factors, including changes in the accretion disk, the jet itself, and interactions between the jet and surrounding matter. So each of these components plays a role in the dynamic show we see from Earth.
It seems like every answer we find just leads to more questions.
That's what makes it so exciting, though, isn't it?
It is. That's the beauty of scientific exploration.
Always pushing the boundaries of our knowledge.
And the pursuit of these answers drives our understanding of the universe forward.
It's been an incredible journey, exploring the world of blazars with you. Thank you so much for sharing your expertise.
It's been my pleasure. I hope our conversation has inspired listeners to learn more about these fascinating and enigmatic objects.
And to our listeners, we encourage you to keep exploring the wonders of the cosmos. Until next time.